So let's move on. Our next speaker is Anna Gubanova from Skoltech. Anna will talk about proxy capacitance resistance modeling for field development optimization. Anna, please go ahead, share your screen.
Good afternoon, dear colleagues. Can you see my screen?
Yes, but could you please make it the slides, the full screen?
Yes.
Yeah, now it's good.
Yes. My name is Anna Gubanova, and scientific supervisor is Dmitry Karateev. I would like to tell you about approximately the same topic, but with some different extensions of CRM. The general target of our project is to create real-time field development optimization system, which consists of two blocks. One is development of Proxy CRM, which allows to forecast production rates. And another block is development of recommending system based on Proxy CRM model. Operational envelope is all assets which have production history long enough to perform optimization. In terms of drainage volumes, CRM could be divided into 5 types. From the simplest ones to the more detailed. We use in our case CRM IP model, which is injector producer prey based. It calculates weight coefficients for each injector and producer well pairs. This is the main equation of capacitance resistance model, which is derived out of two main hydrodynamical equations. They are mass conservation law and Darcy's law. So this system gives us differential equation which has an analytical solution. We have tau and lambda coefficients there, which tau coefficient reflects fluid storage between well pairs, and lambda coefficient describes geological connectivity between well pairs. So to make predictions of total liquid rate for considered well, we should use production history we have and perform production and injection history and perform optimization on lambda and tau coefficients. Results we derived turned out to be quite good with the high coefficient of determination. We trained a model and found coefficients on 70% of our data history, which marked with dashed line here. And after this dashed line, we made predictions. And we got quite satisfactory results for this simple 2D model with heterogeneity inclusions, high permeability inclusions. Also, we incorporated so-called time dependence of weight coefficients. We may simulate shutting of producing well by put at its place a new injection well with the same injection rate as the producing well. These are results for two show how this model works. So we update our coefficients at this place where we perform, where we shut in the first producing well. And we see that without weights update, we got absolutely unsatisfied results with bad predictions. And when we update weights with small additional value, we get very good predictions. Also, we considered more complex model of SPE10, more heterogeneous model, and performed separation of liquid into oil and water phases by using Buckley-Leverett model. So we performed just second stage optimization on liquid production and divided it into separate phases. The results are also good enough. Also, we propose the method to model complex wells with different directions, and it may be performed by using vertical wells into each place along the trajectory of directional well. Since this approach will result in more complex model with much more big number of coefficients, we also propose the scheme of data reduction. We can present our equations of CRM model for each well into the matrix form and perform singular value decomposition and shrink that data to minimize errors and perform and leave less number of coefficients we should optimize. Our further development prospects are to extend CRM applicability for low water cut, since now it's more useful for, it's more appropriate for big water cut values only, and also incorporate gas phase, the effects of aquifer, and the fluid flows between drained volumes, and perform time reduction for calculations by using SVD method. Generally, that's all I wanted to tell you. Thank you for your attention. You may ask questions.
Anna, thank you very much. It was very precise and you are exactly on time. So we even have like not 5, but 7 minutes for the discussion. So please go ahead. Whoever wants to ask something, try to raise your hand. And if I'm not reacting, please speak out loud, because I do not see everybody, unfortunately, too many participants.
I can't see messages. Is there any?
Alex, maybe I can ask a question.
Sorry? Maxim, is it you? Okay.
It's
from Maxim, and then we have a question from Nikolai Smirnov. Okay,
yeah,
Maxim.
okay. One question: why your approach is not applicable for low water cut? As I see in your models and your mathematics, there is no limitation for low water cut.
Yes, but since these cases were quite simple, we performed match procedure quite well on the low water cut. But in general, CRM is useful for steady state regime where water current is high enough. I mean, it's inappropriate for unsteady mode on the first stages.
Okay, it's clear. Thank you.
Okay, thank you. Nikolai, please go ahead.
Okay, thank you. Anna, as we all know, there are just two methods to test any software. First is validation, which means comparing with the real field data. And the second is verification. It is, that means comparing with some exact solutions or benchmark detailed numerical simulation. So here, as far as I could understand, you used the actual data, field data, to tune your model. That's why, of course, good coincidence is understandable because you determine weight coefficients based on this tuning. This comparison. And then there comes a question, did you try to verify your results? So just using your model, you can try to simulate some simple situation which can be just simulated by one of the simulators exactly, and then you use your fast new model and just compare the results. Did you try this?
Well, exactly this scheme was performed. We simulated production in T-Navigator.
In T-Navigator, yes.
Yes, and then trained our model and made predictions and compared them with the results of T-Navigator.
Okay, but you trained the model with T-Navigator. But my question was, if you train model, for example, with comparing with real field data, then it is worth comparing with the T-Navigator. If you train the model with the T-Navigator, then it is worth comparing with some field data. That will be already validation, not verification, which was not used for training, but you trained the model and then applied to some data set which was not available in course of training, just to validate the model.
So since training was performed on models which are synthetic, we don't have real data for them, only synthetic predictions. Synthetic.
Okay, I see. This is really a problem, but yes, it's really a problem. And comparing two different simulators,
for each
it is not
deposit
the way, because they will provide definitely different results. Okay, thank you. Well, it's really a difficult problem. Thank you. You've done a good job. My congratulations.
Thank you.
Thank you, Nikolai.
Thank you.
Anna, I think we have time for one more question, if there is such a question. I do not see the activity in the chat. Nobody is raising hands. So thank you, Anna. Thank you, Nikolai. Thank you, Maxim, for the good discussion.